In this second video, we're going to look at how to actually now multiply and divide rational expressions. Now, recall when you're multiplying normal numerical fractions, you can cancel before you actually do the multiplication because you can cancel out common factors either inside of a fraction, or you can do what's commonly referred to as cross-canceling, where you cancel the numerator of one fraction with the denominator of the other. So if we look at this example, 3/10 times 5/8. One strategy is just to multiply the top times top and bottom times bottom. But sometimes that makes your numbers get really big. So another strategy is to simplify first. Now in this case, 3/10 doesn't simplify and 5/8 doesn't simplify, but 5/10 actually does simplify because 5 divides into both of those, simplifying this to 2 and simplifying this to 1. Now when we multiply, it's a whole lot easier. We get 3 times 1 is 3 in the top, and we get 2 times 8 is 16 in the bottom. The same exact idea can be applied to multiplying and dividing rational expressions. We can cancel before we do the operation to make our lives easier when we actually multiply everything out. Now for those of you who like a big red box with steps in it, really only two major steps here. Factor and cancel, right, so do the simplifying, and then multiply the numerator by the numerator and the denominator by the denominator. So let's look at this example for multiplying. Our numerator in the first term does not factor at all. Our numerator in the second term does not factor at all. 3 times x plus 12 we actually can factor. That can factor to 3 times x plus 4 if we factor out a GCF. So now we're here. And then we can also factor this other denominator. If you recognize this is the difference of two perfect squares, which means it will factor to x plus 2 times x minus 2. Well now, before we actually do the multiplication out, we can look for common factors, either inside of one fraction or the numerator of one and the denominator of the other. In this case, we can see we have an x plus 2 right here that will cancel with an x plus 2 right here. We also have an x plus 4 right here, which will cancel with an x plus 4 right here. So now, all we have left, remember when these cancel, they don't turn to 0, they turn to 1. All we have left now is the entire top has become 1. So our numerator is just 1 times 1, which is 1. Our denominator is 3 times x minus 2, which is, if we distribute, 3x minus 6. And now we have our simplified answer for our multiplication. Dividing, which is spelled with a G, not an E, only has one more step. Right? Dividing by a fraction is the same as multiplying by its reciprocal, which means that this problem here is actually the same as if we took that second fraction, the one we're dividing by, and we multiplied by the reciprocal. So we flip it over, x minus 3 over x squared minus 9. From here we go through the same exact process because now it's just a multiplication problem. So we're going to go ahead and try to simplify this if we can. Neither of these first two pieces factors at all. X minus 3 also does not factor. However, x squared minus 9 does factor to x plus 3 times x minus 3. At which point we can now see there's an x minus 3 that will cancel with an x minus 3. There's an x plus 3 that will cancel with an x plus 3. And all that we have left now is 1 times 1 in the top, which is 1. And on the bottom, all we have left is 3x. Which means that is our final simplified answer to this division problem. Last one up. We're going to make this one messy. So again, starts with division, which means we should rewrite this as a multiplication problem. I'm going to move this over a little bit so we have a little more space here. So again, we don't flip the first one, we flip the second one because that's what we're dividing by. So I'm just going to rewrite that first term again. And then we're going to do multiplication by the reciprocal, which is x squared minus 1 over x to the 5th minus x to the 4th minus 2x cubed. Now let's get into factoring. Let's try to break this down. In the first numerator here, I notice we can take out a GCF. X cubed goes into both of those, leaving us with x squared minus 4. In the bottom, well, there's no GCF here, but it is a quadratic that will factor into two linear terms. Specifically, it will factor to x minus 2 times x plus 1, because negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1, which is that negative 1x in the middle. The numerator also factors, that is x plus 1 times x minus 1. It's the difference of two squares. And the denominator, in this case, has another GCF. It has x cubed again. So x cubed times x squared minus x, x squared minus x minus 2. So it actually factors very similarly to what we already had in the other denominator. We can keep factoring here actually, because x squared minus 4 factors again. So this is really x cubed times x plus 2 times x minus 2. And then the denominator here is already done. Oops. X minus 2 times x plus 1. And over here, x plus 1 times x minus 1 is our numerator. Over this also factors again, x squared minus x minus 2. We already factored one time before. This is x minus 2 times x plus 1. Again, you can see a lot of factoring in this unit. So now we should start searching for stuff that cancels. Well, right away we can see we have an x minus 2 here that can cancel with an x minus 2 right below it. We have an x plus 1 here that can cancel with an x plus 1 here. And we have an x cubed here that can cancel with an x cubed here. And I don't think anything else cancels because we have x plus 2 and x minus 2. That doesn't cancel. We have x minus 1, we have x plus 1. That also doesn't cancel. So now, let's multiply. So x plus 2 times x minus 1, that is going to be x squared plus 2x minus 1x minus 2. We're foiling. And in the denominator, we have x minus 2 times x plus 1. Well, we already know that originally was x squared minus x minus 2. You can also just go ahead and FOIL that one the same way. We can simplify that top a little bit because they're like terms. It's x squared plus x minus 2. And the denominator is x squared minus x minus 2. And now we're done.